Hey, we're gonna work with some complex numbers. There are tons of things you can do with them, and there's a bunch of rules. We're just gonna look at what would happen if you knew that the roots or the zeros were given to you and they happen to be imaginary zeros. And could we write the equation of the original function? We're doing this in a simple manner. We're not worried about where the vertex is necessarily. I just want us to work with multiplying these two things. So what we can do is, since we're given the zeros, we can set it up into intercept form. And when we have intercept form, we're just going to take the two factors here, or two zeros, I should say. There's zeros when they're like this, and when they come into the factors, we change their signs. But as you can see, when we change these signs, they're kind of just like they were, because there's a positive and a negative version of those. And then all we have to do is FOIL. So when we FOIL, we have x squared, and now we have plus 6xi. The inners are negative 6xi. And the last are negative 36, and you have two i's, and we treat them kind of like variables. So 36i squared. We'll see that these two cancel in the middle, and we'll have x squared minus 36 times I squared. But we talked about, when we took the notes, what I squared is equal to. I squared is actually equal to -1. So when we go ahead and make that change, we have 36 times -1, and we have x squared plus 36 equals f of x. So this is a possible function that would have these two zeros. It could be all multiplied by a larger number and still get the same. But here's what we get: 4 zeros when we solve here. And if you don't believe me, let's just do a quick thing over here. If f of x equals x squared plus 36 was given to us, and they asked us to find the zeros, well, I'm going to solve it using some square roots because that's the easy way. And we'll subtract 36 over equals x squared. We would want to take the square root of each side. So this here is going to be, 6i equals x, because the square root of 36 is 6, square root of -1 is I. So positive 6i, negative 6i, and those were our two zeros up here. So let's try one more when it's a little more difficult. Here we have the roots being I square root of 7 and negative I square root of 7. So we're still going to set it up in intercept form. And we have x minus I square root of 7, x plus I square root of 7. All right, and we're going to FOIL once again. So we have x squared. We have positive, there's a variety of ways to write it. I'm going to write I square root of 7x minus I square root of 7x. These are all multiplied, so it really doesn't matter what order we write them in. I'm writing them in the coefficient and then the variable, coefficient and the variable. And now let's multiply these two things together. So negative I square root of 7 times I square root of 7. So I have I times I, so that's going to be I squared. And we have square root of 7 times square root of 7. And there's a variety of ways we can write that, but I'm just going to simplify it for the inside, so we can see what happens. So this right here came from I square root of 7 times positive I square root of 7. That's where this came from. All right, so let's simplify. X squared These two cancel. And I'm left with negative I squared square root of 49. And we can simplify this over here. So I'll have x squared. Well, we know that I squared is really equal to negative 1. And I also know that the square root of 49 is equal to 7. So we have a negative or a minus sign times a negative 1. So that's going to end up being positive. And if that's positive 1, we just look over here and say, well, what's that? That's 7. So f of x equals x squared plus 7.